Okay, so I'm sorry that I didn't start this earlier, but we're doing resonance structures. I'm videoing now. So we're doing resonance structures. I'm just backing up a little bit. All right. And so we're doing resonance structures and we're doing them, we're not doing resonance structures. We're doing structures for ions, for polyatomic ions. Review for you guys. And so what we're doing is, for the polyatomic ions, we're going to add or subtract electrons. For the ions, then we're going to write the structure like we normally do, and we're going to put it into brackets and put the charge outside the brackets. So we just did hypochlorate. We took the 7 for the chlorine, the 6 for the oxygen, gave us 13 electrons. We added 1 electron for the charge, giving us 14 electrons. We divide by 2, giving us 7 pairs. Chlorine and oxygen, 1 bond between, leaving us with 6. When we put our six pairs around, that gives us a perfect access of 8 to each atom. We put it into brackets with our charge outside. Now we're going to do ammonium. So nitrogen has 5. We have 4 hydrogens. So 4 times 1 is 4. So 5 plus 4 is a total of 9 electrons. So for the positive, we're going to subtract 1 electron for the positive. That's going to give us a positive charge. That gives us 8 electrons divided by 2, which gives us 4 pairs. Yeah.
Will we ever get an odd number of electrons?
Okay, so will we ever get an odd number of electrons? Yes. The answer is it is possible to get an odd number of electrons. Once, years ago, I mean like 15 years ago, there was a question on the test where there was an odd number of electrons, and people went berserk over it because it was such an unfair question. The answer is that if you get an odd number of electrons, the highest electronegativity gets that electron, which makes sense. It makes sense because the highest electronegativity is going to draw that electron. So that's where that single electron would go, because ultimately that electron would be pulled between two elements, because it would be missing one. So that pair would be like somebody would have to be missing a pair, and so the highest electronegativity would get that one. But it's not something that will show up on a regular basis, so we don't use it in practice. So probably none of the homework problems that you have would have it, because it's just not something that happens on a regular basis, and you should not expect it on the test. But if it ever happens, the logical answer is it goes to the highest electronegativity, which is the highest to the right on the periodic table, which again is not an answer to a test question. Physical presence on the periodic table is not an answer to a test question and will not get you the points. So here we go. I look and I'm making a wheel. So what goes in the center? Nitrogen. And then all I have to do is put my hydrogens around because I'm making a wheel. Okay? Now I'm going to put my 4 bonds. I only have 4. 1, 2, 3, 4. That's it. Now, has everybody access to 8 and 2 if they need it? Well, all my hydrogens are good because they all have access to 2. And my nitrogen has access to 8. So we're good. I put my bracket. And outside I'm going to put what? A plus sign. And that indicates that I took 1 electron away. Okay? All right. Now lastly, we have resonance structures. Now, resonance structures are a little complicated, but they can show up on the test. And they show up in many different ways. So I'm going to show you a couple different ways that they can show up. Resonance structures are when two or more structures will satisfy the structure for one compound. What? Right. So let me give you an example. Ozone, O3. So I have 3 oxygens, which is 3 times 6 is equal to 18 electrons, which is equal to 9 pairs. So I set this out and I go 1, 2, 3. 9 pairs. 1, 2, and now I'm going to switch over to pencil. Okay. 3, 4, 5, 6, 7, 8, 9. Okay, so there's a problem, right? My middle oxygen is short. So I do this, move one in. Sorry, I move one in as a double bond. Okay, so now everybody's happy. Good, we're good to go. The question is, why this oxygen and not this oxygen? That's the resonance question. Why did this oxygen, so if I number them, 1, 2, and 3, why is the double bond between 2 and 3 and not between 1 and 2? Does that make sense? This is called a resonance structure. And it resonates. So there are 2 structures that belong with this O3. It resonates between the 2. Now, actually, I want to be clear about something. The actual structure looks like this. It's what we call a hybrid. All right? Where 1/2 of the structure is between 1 and 2, and 1/2 of the structure is between 2 and 3. And ultimately, this makes a lot of sense because we're talking about electron clouds. We're not talking about like orbitals like Bohr's, you know, oh, they're in direct pathways, so one's going to jump to the other side. That's not what's happening. These are electron clouds, and so it's a hybrid structure. Now, how does this show up on the test? So it shows up in a couple different ways. One, they could ask you for the hybrid structure. They literally could say, show the resonance hybrid structure. 2, they could say, show one of the resonance structures. This will work. 3, they could say, show all of the resonance structures. Both of them, with the arrow in between. So resonance structures are a very tricky thing on the test, because you have to understand that this bond goes back and forth and it's more than one structure. Now, how do you know if it's a resonance structure? Because you have to ask yourself, why here? Why not here? All right? It is not the case that this would be a chlorine and this would be an oxygen, because that's not a resonance structure. The resonance structure is going to be between two oxygens or two chlorines, that kind of thing, right? And again, we've got practices. Okay? All right, this is a resonance hybrid, and the electrons are delocalized, and they are spread out. And the molecule is more stable when it's in this hybrid formation. But to be clear, if you draw the hybrid structure, when they ask for one of the resonance structures, that is not what they're looking for. When they're asking for one of the resonance structure, and we'll do sample free responses, when they ask for one of the resonance structures, they're looking for this or this. They specifically use the word hybrid when they want this, and I've only seen it once. They usually ask for this or both of them. Okay? So let's look at nitrite. I have nitrogen, which is 5. 2 oxygens, which is 2 times 6, which is 12. That gives me a total of 17. I'm going to add 1 electron, which gives me a total of 18, which is 9 pairs. Now I'm going to draw my structure. My nitrogen is in the middle. That's 2. 3, 4, 5, 6, 7, 8, 9. What's wrong? Sabrina? Good. So I'm going to take 1 from my oxygen and move it in. So now everybody's happy. The question is, why this oxygen? Why not this oxygen? So now I have a resonance structure. I draw this oxygen, and I move my double bond to the other side.
So when you have resonance, you just draw both of them?
Yeah, you just draw both of them. Unless they just ask for one, which they do. They often just say, just show one of the resonance structures. Again, the thing is, they want to know that you know what a resonance structure is. So they're assuming that if they say on the test, draw one of the resonance structures, that you're not going to go, oh no, what's a resonance structure, right? But if you know what a resonance structure is, then you can just draw one of them, right? Yeah.
So then when will they ask for like the hybrid?
So the question would give you this, and it would say, draw the hybrid.
Okay.
Yeah. And I've only seen it once. Because this is like a controversial thing, not resonance structures, but like how do you ask for resonance structures? That's the controversial thing. And by the way, there are resonance structures with 3 resonance structures. Although I think I've only seen like draw one of the resonance structures for a 3. For a compound with 3, I think that the question was draw one of them, right? So if it says draw one, you can just draw the structure. Just draw the structure, right? Just know that it's a resonance structure. Okay? All right. So now, let's talk about formal charges. So, Charges are assigned to each atom if all the bonding electrons were shared equally, but they're not. They're not all shared equally. And so we have this thing called formal charge. Now I have to tell you, I taught this course for years. I mean, like, I've taught this course for 20 years, probably 20 years, maybe more. And I didn't teach formal charge until probably like 3 years ago. I didn't even know what it was. And then there was a question, a direct question on the test, and the kids came back and said, "What's formal charge?" And I was like, "I don't know." I didn't even know what it was. So formal charge is when there is more than one possible structure for a Lewis dot structure. One of the structures will be more stable than the others. And the way you, so you would say, which one of these would it be? And how do we know? Well, the way you know is by calculating formal charge, and then the sum of the most stable will be 0. The sum of all the formal charges in an ion has to be equal to the charge in the ion. And the small or 0 formal charges on an individual charges are preferred over the large ones. So if you don't have 0, then the smaller the formal charge, the better. And when formal charges can't be avoided, the negative must reside on the most electronegative atom. So now let's see where they are. The formal charge, you take the valence electrons minus the lone electrons minus half of all the bonding electrons for each element, each atom. All right? So this is very, very complicated. So what I'm thinking right this minute, what I'd like to do is set this aside for right now, because after teaching this for so many years, I kind of feel like this is a pain in the butt for very few points, and this is like low chance that it's going to come out on the test and low points that it will come out on the test. But we should do it. We should do it, and you should know how to do it, but not right this second. We shouldn't, because we should do Lewis dot structures right now. So let's, because there are, see, like I assigned the formal charges. I have practice problems. So let me check and see what we have for the packet. Yep, exceptions to the octet rule. So let's do Lewis dot structures on the practice packet for the rest of today, and then next class we'll finish the packet, we'll do exceptions, we'll practice formal charges because we'll have Lewis dot structures done, and then we'll take the Lewis dot structures, we'll do formal charges and exceptions. Okay? All right. So I put together, I have a packet here. This is a packet that I give to my honors students, but it covers everything that we've done. And everything except exceptions are here. And formal charges aren't in here. So they're not stapled because I copied them really fast this morning. So I just need to staple them. It starts with elements. The first, is this somebody?
Oh my God.
That's right. No. It starts with the first 18 elements, so you can skip that page if you know how to do the first 18 elements. But if you did not take chemistry yet, you may want to do the whole packet, which would be the first 18 elements. And I'll do like the first 3 on the first page with you. Like I'll do the first few with you, you know. And it does have ions in there with you also. So you have ions. Okay?